Welcome to Math with Professor V. This is a video lecture for section 4.5 for business calculus on derivatives of logarithmic functions. So first we're going to learn the rules when you take the derivative of logarithm with base a of x and then natural log of x. So the derivative with respect to x of log base a of x is 1 over natural log of a times x. And then if your base is already e, Euler's constant, then the derivative of ln of x with respect to x is just 1 over x. Okay, actually, this is a more specific case of this general formula for differentiating logarithms because, like I said, when you have natural log of x, that means log base e of x. So if you apply the first differentiation rule for log base e of x, ln of x, then it's 1 over ln of e, which is just 1, times x, which is why we get 1 over x. That's just 1. Okay, if you need to review your logarithm properties in more detail, then I'll link a few videos in the description, just in case you're a little bit rusty. So let's apply these new differentiation rules and find derivatives of some functions. So find the derivatives of the following functions. First one we have is just plain old y equals log of x. This is a common log. When we don't write the base, it means it's assumed to be 10. So if you want to go ahead and put that in so you know, and it's staring at you in the face, that might be helpful. And then let's go ahead and take the derivative. Basically, look at this first boxed rule here. The base is 10. A is 10 in this case. So dy dx, or you could write y prime, is going to be 1 over natural log of a, in this case is natural log of 10, times x. You can leave it like this. You can leave it like this. You can also do a little switcheroo if you want to put the x in the front and then the ln of 10 after. No one's going to be angry about that. That might even be more clear. You decide, okay? Or check with your instructor if they have a preference. Okay, next one, y equals 7 times natural log of t. Now, no, we're not going to do the product rule because 7 is just a constant. There's no variables there. So remember, when you have a constant times a function and you take the derivative, the constant just comes along for the ride. So dy dt, 7's coming along for the ride. Don't mind him. And then derivative of ln of t is 1 over t. Okay, that's really all that there was. This is 7 over 1 times 1 over t, which is going to be 7 over t. Let's box it and move on. C, y equals natural log of negative 4x. Okay, y prime, I'm switching up the notation just so you guys are used to all of it. dy dx, dy dt, y prime. So derivative of natural log of negative 4x. This time we have to do the chain rule. So I want you to go back, look at this rule. Derivative of ln of something is 1 over the something. So that's what we're going to do here. This whole negative 4x, that's the something. So derivative ln something, 1 over the something. Then by the chain rule, I have to multiply by the derivative of the something. So what's the derivative of negative 4x? Very good, it's negative 4. And then notice here, the negative 4's cancel. And for my final answer, completely simplified, we just have 1 over x. Wow, wow, wow. Okay, now let's try one where we do actually have to do the product rule. They're getting spicier. Hang on. So here we have y equals 3x plus 7 times ln of 2x minus 1. So product rule is required because here we have a function of x times another function of x, and we want to take the derivative of this product. So dy dx is going to be, first let's take the derivative of 3x plus 7, it's 3. Then you leave the other guy alone, leave ln 2x minus 1 alone. It's not his term, they got to take turns. Plus, now I leave 3x plus 7 alone. Already had his term. Now derivative of ln of 2x minus 1. Derivative of ln of something is 1 over the something. And then by the chain rule, I have to multiply by the derivative of the something, of what's inside the parentheses. So derivative of 2x minus 1 is just 2. Good. And then let's see, so this is just 3 ln 2x minus 1. That doesn't clean up. Plus, if you want, we could put both the 3x plus 7 and the 2 in the numerator. Let's put the 2 in front. Then you have 3x plus 7, and this is over 2x minus 1. If you want, you could distribute this through or not. We could get a common denominator, but it's not really going to help things out, especially because this is natural log already. It's not going to clean up. I say let's just stop while we're ahead and box it. Okay. Lovely. Now, occasionally you'll see an absolute value around the argument for natural log. So just as a note, add this to your list. If we take the derivative with respect to x of the natural log of absolute value of x, then it's still just 1 over x. The reason being, if you rewrite absolute value of x as a piecewise function and you take the derivative and you apply the chain rule, it simplifies to the same result regardless, which is nice for us. So basically, just don't stress when there's absolute value bars. Carry on and drop them. Okay, so here we go. We have the derivative of y equals x times natural log absolute value 2 minus x squared. So you guys, we got to do product rule for this one. Oh yeah, here's one function of x times another function of x. Okay, hop to it then. So dy dx equals derivative of x is 1. Then you leave that ln absolute value 2 minus x squared alone. Plus, now I'm going to leave x alone. Derivative of ln of 2 minus x squared absolute value is just 1 over 2 minus x squared. You don't need to keep the absolute value. See how they're gone now? They're gone now. Times the derivative of what's inside. So times the derivative of 2 minus x squared. We're doing the chain rule, which is negative 2x. Okay, good. And then we can clean up a little bit. So ln absolute value 2 minus x squared. This one keeps its absolute value bars because I didn't take the derivative, right? This time. So that stays. And then if I simplify x times negative 2x, I'm going to have minus 2x squared in the numerator over 2 minus x squared in the denominator. And that's it. Very good. Okay, let's try now using the quotient rule. Ooh. So here we have y equals negative 2 ln of x over 3x minus 1. So dy dx equals, we've got low d high, so denominator, times derivative of the numerator. So no product rule necessary. Just keep that negative 2 times derivative of ln of x, that's 1 over x. So this is low d high minus high, so minus 2 ln of x. And then I need d low, derivative of the bottom, derivative of 3x minus 1 is just 3. Over low low, 3x minus 1 squared. Okay, now at first glance, I'm like, oop, we've got a problem because we have a fraction inside of a fraction. I have a fraction in the numerator. That's a big no-no. That's called a complex expression, and it's not considered simplified. So what to do, if you want to get rid of an extra denominator, you multiply everybody by that denominator, by the LCD. So in this case, I just have to get rid of x. Here's one term, 2 terms in the numerator. They each are going to get multiplied by an x, and then the denominator needs 1 as well. That way, really, all I did was multiply by 1. I multiplied by x over x. This one in the numerator got distributed across, and then this one just goes right here, okay? Now, I'm not going to see anything happening with this one because it's just going to cancel. So now I'm left with, let me put the negative 2 in the front. It'll look better. 3x minus 1. Are we good? And then all of this is going to simplify to plus, because these negatives cancel, 2 times 3 times x, that's 6x ln of x over, and then just leave it, x times 3x minus 1 squared. Okay, we can distribute that negative 2 to 3x minus 1 if we want. So let's see, that's negative 6x plus 2 plus 6x ln of x over x times 3x minus 1 squared. You could stop there if you like. Alternatively, if you want to take a negative 2 out of everybody in the numerator, go for it. Take a negative 2 out. Now this is 3x minus 1 minus 3x ln x. And sometimes we do like to factor for part of our final answer, because coming up soon, we're going to be taking our derivatives, setting the numerator to 0, setting the denominator to 0, and it's just easier if it's already factored. Okay, sneak preview, this is going somewhere. Okay, one more thing that's really nice when we take the derivatives of logarithmic functions is we can make use of properties of logarithms to make our calculus job easier. Yes, so I'm going to remind you a few of your log properties just in case you forgot. But like I said, I'm going to link some videos in the description, properties, if you need to just review them, okay? So first one is if you have natural log or any kind of log, it doesn't have to be natural log, but that's the most common one that we use, of a times b. So you have a product in the argument. This is called the argument. Then you can rewrite it as the sum of two natural logs. So ln of a plus ln of b. And then if you have ln of a quotient, a divided by b, that's ln of a minus ln of b. And then if you have natural log of a raised to the b, you can bring that exponent on the argument down front and multiply by it. It's b times natural log of a. Now this one's a little dangerous for students because be careful, that exponent has to apply only to the argument a. If you have natural log of a raised to the b like that, don't touch it. You can't do anything. Don't move that exponent. Don't even think about it. Okay. Ooh, I know, a little dangerous. Okay, good. Very good. So now let's see if we can put these properties to use before we take derivatives, because we want to simplify as much as possible. So find the derivatives of the following functions. First one we have is natural log 3t squared plus 7t minus 4 to the 5/3. Now, remember, when you have derivative of ln of something, you do 1 over the something times the derivative of this whole thing. And the derivative of this, oof, it would be such a nasty little chain rule. You'd have to bring the 5/3 in the front, leave this alone, subtract 1, then multiply by the derivative of the inside. It's sounding like quite a task. But then you might think to yourself, I don't need to do all that, because this exponent, this 5/3, is basically b right here. It applies only to the argument. I'm going to move it down front of the logarithm, and then I don't have such a nasty chain rule to contend with afterwards. So I can write this as y equals 5/3 times natural log 3t squared plus 7t minus 4. Okay, so now when I take the derivative, dy dt, 5/3 just comes along for the ride. Derivative of ln something is 1 over the something. And then I'm going to teach you a shortcut. Instead of doing times the derivative of the something off to the side, we're just going to automatically put it in the numerator. So the derivative of 3t squared plus 7t minus 4 is 6t plus 7. Oh yeah, it's a good little shortcut, isn't it? And then I would say from here, just clean up, put everything in the numerator together. You can distribute if you want, but I would just leave it factored. So 5 times 6t plus 7 over 3 times 3t squared plus 7t minus 4. How was that? Nice, right? Okay, so we got our log properties helping us out, and I taught you a cool shortcut. Let's try another one, see if you've got it under control. Y equals natural log of x to the 5th times x squared plus 5 to the 10th. Again, if I just took the derivative straight away, you would have such a nasty chain rule because I'd have to do product rule. Oof, no fun. Instead, I'm going to say, all right, I can write this as y equals natural log x to the 5th plus natural log x squared plus 5 to the 10th. And no, I'm still not going to take the derivative just yet. I'm going to move these exponents down front first. So I could write this as y equals 5 ln of x plus 10 ln of x squared plus 5. Now it's as expanded as possible, so we can go ahead and take the derivative. So y prime is going to be 5 times derivative of ln of x is just 1 over x, plus 10 times, and then let's use our little shortcut here. So derivative of ln something is 1 over the something, and then by the chain rule, the derivative of the something goes in the numerator, which is going to be 2x. Fabulous, very good. Okay, so this is gonna end up being 5 over x plus 10 times 2x, that's 20x over x squared plus 5. Now, typically you wanna get a common denominator with your derivatives. Sometimes your instructor might let you stop here, okay? So if they let you stop, then stop. But if not, let me keep going and show you what to do. If we need to get a common denominator, the LCD is x squared plus 5. So this one I'm going to multiply top and bottom by x squared plus 5. And then this one just by an x. So then we're going to have 5 times x squared plus 5 plus 20x squared over x times x squared plus 5. So this is going to be 5x squared plus 25. 5x squared plus 20x squared is 25x squared plus 25 over x times x squared plus 5. How can we not take that 25 out? I just think it's asking for us to please factor me out. 25 times x squared plus 1 times x times x squared plus 5 in the bottom. Good. That's that. Let's try one last one, and I think you guys are good to go. So y equals natural log of x squared minus 4 over x cubed. Again, do not do some nasty chain rule involving the quotient rule. Go, oh, this is a natural log. I can rewrite it as natural log x squared minus 4 minus natural log of x cubed. Now, can I expand further? Yes. I can definitely move this exponent down front. I could factor this if I wanted and split it up and take the derivative, but since you saw at the end we always get a common denominator, I don't really want to split this up anymore. This won't have a bad chain rule, so I'm just going to leave it. So let me just leave that first term alone, but I will bring down the 3 here, so minus 3 ln of x, okay? So now let's go ahead and take the derivative. So y prime is going to be, so derivative of ln something is 1 over the something, and then by the chain rule, the derivative of the something goes in the numerator, minus, and then this is going to be 3 just comes along for the ride. Derivative of ln of x is 1 over x. Let me just put 3 over x. I think you guys got it at this point, right? Okay, so this is one option. Some instructors might let you stop there. But let's keep going, get a common denominator. So y prime is 2x over x squared minus 4 minus 3 over x. I'm going to multiply this guy by x, top and bottom, and then this one by x squared minus 4. So then we're going to have 2x squared minus, let me distribute at the same time, 3x squared plus 12. Remember, the two negatives cancel. And then I have x times x squared minus 4. So what's this going to give us? Negative x squared plus 12. Let me put the 12 in the front. It'll look better. 12 minus x squared over x times x plus 2 and x minus 2. And that's it. All right. Good job. So just add this to your little arsenal of differentiation rules. And the more you practice, then you'll remember them. It'll become second nature. And like I said, we most often work with natural logs, but once in a while you'll have to differentiate a logarithm with a different base. So don't forget that rule as well. All right, that ends the video. Don't forget to give it a thumbs up. Subscribe if you haven't already. Stay tuned. More business calculus video lectures coming your way. And if you need to review any of your algebra or other topics, then check out the videos on my YouTube channel that are organized into playlists. You can also follow me on Instagram, TikTok, Twitter, Math with Professor V. Thank you guys so much for your support. I'll be back sooner than later. Bye-bye.